All right, let's take a look at lesson 9.6, dilations. You can use the scale factor to make a larger or smaller copy of a figure that is similar to the original figure. So we did this when we studied similarity. We always found the scale factor from one figure to the other. So remember, when things were similar, they had the same shape, angles were the same, sides were proportionate. So the scale factor is that proportion between the two, the ratio of the two corresponding sides. A dilation, okay, is where we make something larger or smaller. You're always going to have a center of the dilation, some point, that reference point that where we start, and we are going to dilate it from that. The scale factor, okay, which will use the letter N to represent our scale factor, is the amount that we're either going to increase something or decrease it. So the scale factor is always going to be greater than 0, not a negative scale factor. So the way we write in function notation is we use a capital D for dilation. The subscript of N is the scale factor, and the next point is going to be the point, the center of dilation. Now, if there's not one here, if they just put the scale factor, then that means it's going to be on a graph, and that's the origin. So a dilation is a transformation with the following properties. The image of C is itself, C prime. For any other point, which in this case is R and R prime, just for an example here, the distance from C to R and the distance from C to R prime is going to be how we calculate our scale factor. So we have this equation here, and let's kind of get a better look at it here. I'm going to show you what we're talking about. This is the image, okay, is equal to the scale factor times the pre-image length, okay. So if you divide it here by the, the pre-image length, it's going to be the image over pre-image is equal to your scale factor. So what I would do is I'd kind of write yourself a note, and where N is our scale factor, it is going to be the image distance over your pre-image distance. So pre-image distance is on bottom, image distance is on top. Just like it is here, sometimes it's easier to look at the scale factor like so. Now dilations only preserve angle measure, not distance. So this means this is not a rigid motion. All right, so let's take a look here. A dilation is either an enlargement of the scale factor of N when it's greater than 1, or it's going to be a reduction when the scale factor is between 0 and 1. So if it's a fraction less than 1 and greater than 0, it's going to be a reduction. If the scale factor is greater than 1, it's going to be an enlargement. If it's equal to 1, it is congruent. It's the same figure, same size. So if you look at our figure here, we can take two corresponding sides, and we see that A, B, C, D is our pre-image, and A prime, B prime, C prime, D prime is our image. So we take the numbers that we're going here. We remember it's to find the scale factor, it is the image, which is going to be the 4, over the pre-image, which is 2, which gives us a scale factor of 2. This is an enlargement, and we've increased it by 2. Okay. Now, that's just one way to find the scale factor. Okay, so we're taking corresponding sides. We could have also used the measurement from A to D prime over A to D if we knew those measurements. So let's look at here. We have the measurement here of C. Center of dilation is at C. We have our figure EFGH, which has a side length of 8, and E prime, F prime, G prime, and H prime with a side length of 2. So that means, remember, to find the scale factor, we're going to take the image, which is going to be 2, over the pre-image, which is 8, and reduce the fraction, and it becomes 1/4. So we have a scale factor 1/4, which means we've reduced it. Now, one other thing I was going to show you here, in this case it's very easy to see that if you start for the center of dilation and you draw a line to the image point, it should go through the pre-image point. So if I drew a line from here all the way to here, it should go through its pre-image point. And same thing for this, and same thing for C. So we can also look at the distance here. So that means I drew through here. I could draw to each one of these here. The distance from C to E prime is going to be proportionate, the same scale factor as from C to E. So this number would be on top, this number would be on bottom, and then we can get our scale factor. So there's a couple ways to find that. So remember, it is the image distance over pre-image distance. All right, so let's look at the first example, finding the scale factor. Is the dilation of n of x, x is our center of dilation, of triangle XTR equal to triangle x prime t prime r prime an enlargement or reduction? And then what is the scale factor? So as you look at this problem here, notice that our point here is x. This is our center of dilation right here. Now our image is the one over here in blue. It is much larger than our image right here, our pre-image, which means this is going to be an enlargement. So we have an enlargement. Now to find the scale factor. So we need to take either two corresponding sides, or we need to take the entire length of the pre-image distance over the image distance, which is going to be the same thing. Or image distance over pre-image, I'm sorry. So the scale factor, we need to find the image distance. Well, that means how far is it from x to t prime? And that distance here would be 8 plus 4, which is going to give us 12. So we added 8 plus 4 to get that 12. Okay? Just if you're wondering where that came from. So now the pre-image distance is going to be from x to t, which is going to be 4. So another way I could write the scale factor would be the distance from x to t prime over x to t. That's 12 over 4, which means it's an enlargement of 3. So we have a scale factor of 3. Everything is 3 times the length. Now you could also look here and take the two sides, which is basically what we did here. Is if you remember, we added these two up here. 8 plus 4 is 12. You can't take this and say 8 over 4 and get 2, because that's not correct. We need the entire length of the line segment, and that's where we have to add the 8 plus 4. All right, so let's take a look here. I want you guys to find, first of all, is it an enlargement or reduction, and then find the scale factor. So pause the video, calculate it, and come back to see if you got it correct. All right, so once again, we can see that this is a reduction. The image is smaller than the pre-image, so we've reduced it here. To find our scale factor, what I did is I chose the distance from the origin O to K, from here to here, and then the distance from here to K. So we got O to K prime over O to K. So I can calculate those distances easy because I can count them. They're on the x-axis, so they're a horizontal line. Now I could have also done from O to J. So from the origin to J prime is going to be 1, and from the origin to J is going to be 2. So that's going to be 1 over 2. Okay, I wouldn't probably want to do from here to here, because this would have caused me to have to use the distance formula. Not that you couldn't do it, but you could. And this one here to here would also cause me to use the distance formula for both. So the quickest route is always look for some horizontal or vertical line that we can count in order to use our length, since they didn't give us the lengths here. So our scale factor would be 1/2. All right, so let's take a look at finding a dilation image. Okay, what are the coordinates of the vertices of the dilation of 2? So since there's not a parentheses here in the center of dilation, we're going to assume that it's going to be the origin. So of triangle PZG, graph the image of PZG. So first of all, start off this problem by writing down the coordinates of the original triangle PZG. So we got P, we have Z, and we have G. So we're going to write these coordinates here. Now P is located here at a positive 2, so these are each 1, 2, so this is positive 2 and down 1. So positive 2 and negative 1. Then we have Z. Z is going to be at negative 2 and positive 1. So negative 2 on the X and positive 1 on the Y. And then G is going to be at 0 on the X, and we're going to go down 2 on the Y. So now we're going to dilate this with a scale factor of 2. So you don't have to write the dilation of 2 every time. I'm just going to show you this is what we're doing. And so we're going to get our P prime, our Z prime, and our G prime. So when you take a scale factor, you're going to take this 2 here. So it's a scale factor of 2, which means it's an enlargement. We're going to multiply each coordinate by 2. So 2 times 2 is 4. Negative 1 times 2 is a negative 2. And then we're going to get, once again, negative 2 times 2 is a negative 4. 1 times 2 is 2. And then we have 0 times 2 is 0. Negative 2 times 2 is a negative 4. So these are our new points. So let's take a look and graph our original points. And then you can kind of see how it's dilated. So we have G down here at 2, 0. We have P, which is at 2, negative 1. And then we have Z, which is at negative 2, 1. So we'll draw our line here, connect the dots. Now we're going to mark our image points. So we're going to start with P, which is at 4, going out 4 and down 2. And then we have, this is going to be P prime. And then we have Z prime, which is going to be at negative 4 and positive 2. Z prime, and then G is going to be down here at 0, negative 4. This is G prime. So one thing you'll notice here is if you take and drew a line, it would go from the center of dilation, and you could draw a line all the way through from here to P prime. You could draw it from Z to Z prime, and it goes through both points, and then of course G and G prime. So, and this would be true if it was a reduction as well. So, right now I want you to find the reduction, which is a dilation of a half of triangle PZG. So we're going to take the original image here and we're going to do a reduction of 1/2. So pause the video, calculate this, draw it on the same picture, or you can draw it on a new picture, new graph, and come up with those new points. All right, so as we draw our new points here, we're going to reduce everything by 1/2, which means you're going to multiply 1/2 times 2 and get 1. Negative 1 gets negative 1/2. Then we get negative 2 times 1/2 is going to be negative 1, and 1 times 1/2 is 1/2. 0 times 1/2 is 0, and negative 2 times 1/2 is 1. So this is our new points here in green, and I'll draw the line here. And this represents our reduction of our original dilation points, our pre-image. And so we basically have it's just making a larger, it gets larger and smaller. The same shape, just the sides are going to be smaller or longer in length, depending on if you're doing an enlargement or a reduction. All right, now let's take a look at this last part. Okay, we got it. A magnifying glass shows you an image of an object that is 7 times the object's actual size. So the scale factor of the enlargement is 7. The photo shows the apple seed under this magnifying glass. What is the actual length of the apple seed? So what we're trying to do is find the actual length. So we're going to use the equation where we have it's the image is equal to the scale factor times the pre-image. So we had 2 ways to actually do our scale factor, and this is one of them that we looked at earlier. So let's put in the information that we have. The image, okay, the image here is going to be 1.75 inches. This is the, as it's blown up, we can see it, this is going to be 1.75 inches. Our scale factor is an enlargement of 7. That means it's going to be a 7 here, times our preimage. Okay, so I'm just going to use a P for our preimage here. So 1.75 equals 7 times P. So to solve it, we're going to take and we're going to divide by 7. And 1.75 divided by 7 is going to be 0.25 inches. So our preimage is about 1/4 of an inch, is the original size of the apple seed. So once again, we're going to take the image, use this equation, image is equal to the scale factor times the preimage. All right, so let's take a look at the last one here. The height of a document on your computer screen is 20.4 centimeters. When you change the zoom on your setting on your screen from 100% to 25%, the new image of your document is a dilation of the previous image with a scale factor of 0.25. What is the height of the new image? So pause the video, come back and check your work when you're done. All right, so what they gave us, this is our pre-image here, the height of the document on your computer screen. When we change the zoom, that's going to be the image result, which we're trying to see. So we're going to reduce it from 100% to 25. That's a reduction, which means this is our scale factor of 0.25. And we take times the pre-image distance of 20.4 centimeters, and that ends up with the image going to be about 5.1 centimeters long or high. All right, so this concludes our lesson of 9.6 on dilations.